So, welcome to section 2, exercise 1. So, we need to find a linear change of variables that give a one-to-one correspondence between points on this curve and it's split from one line to another. We'll just write it. So now the system is obvious. Times n to the naught, n to the first, n to the second, n to the third. So to make sure that I'm doing this right, I always need to go back to basics. We have a curve with an equation, yeah, and then we make a mapping where a point is mapped to f of x point y. And we have the mapped curve, and now we need to find, given a point x point y, what is the condition that it lies on the curve. So we go back and ask the inverse point. Does that lie on the curve? They're equivalent. So that means the equation of this one is q of f inverse to x point y. So that is, if we multiply this one by alpha, then we get 1 divided alpha third, 1 divided alpha second. So we need to multiply by so that's n, of course. So the map turns to nx, and then multiply by n to the third. So this is the equation that we do that we work on. No, it's not. It's that one up here. That's the equation we work on. So they are obviously alike. And then this needed to become so if y tends to alpha y, then this n to the third y squared divided by alpha 1, and that should equal n. So this means we have x point y being mapped into nx ny. So that was really a simple linear change, an affinity. All right, that was the first one. Then we have to check this map. So this should have the form. This should be this one should be equivalent with this one. My. So, and that becomes that one. So this mapping, let's call it gamma. Then we get ny squared minus x equals x to the third minus. And then what? Oh, n to the square vanishes, so it's just x, right? So that was the first problem.